In the spring of 1900, a group of sponge divers were blown off course by a storm near the tiny Greek island of Antikythera. What they found 45 meters below the surface wasn't just a shipwreck. It was a graveyard of ancient luxury. Marble statues, bronze treasures, and jars of wine. But among the gold and marble was a small, calcified lump of bronze that nobody cared about. It sat in a museum basement for 2 years until it literally cracked open, revealing something that made historians' hearts stop. Inside were gears. Bronze, hand-cut, triangular gears. Now, that might not sound like much to you, but according to every history book ever written, this level of precision engineering didn't exist until the 14th century. This shipwreck was from 60 BC. Finding this in ancient Greece is like finding a smartphone inside a pharaoh's tomb. To understand why this discovery was so world-shaking, we have to look at what we thought we knew about ancient math. For years, historians thought the Greeks were theorists. They were great at geometry on paper, but we didn't think they could translate that into complex machinery. But there were whispers in ancient texts. The Roman writer Cicero wrote about a sphere created by Archimedes in the 3rd century BC. He claimed it could reproduce the movements of the sun and moon. Most historians dismiss this as a legend, a tall tale. But the Antikythera mechanism proves Cicero wasn't lying. It suggests that Archimedes, the man who gave us the value of pi, might have been the Steve Jobs of the ancient world, designing the first operating systems for the stars. For decades, scientists couldn't see inside the lump without destroying it. It wasn't until the 2000s, when a team of researchers used high-tech X-ray tomography, that the machine's source code was finally revealed. They found over 30 gears. This wasn't just a tool. It was a mechanical computer. You could input a date using a side crank, and the machine would perform a series of complex mathematical calculations using gear ratios to output the exact position of the sun, the moon, and the 5 planets known to the Greeks. This is a physical implementation of a deterministic algorithm. It even accounted for the irregular orbit of the moon using a pin and slot mechanism. Now, let's get into the engineering side. The Greeks knew the moon's orbit wasn't a perfect circle. It speeds up and slows down because its orbit is elliptical. How do you program an elliptical orbit using only circular bronze gears? The creator used something called a pin and slot mechanism. They mounted one gear slightly off-center and used a pin to drive the gear next to it. As the first gear turned, the pin would slide back and forth in the slot, causing the second gear to accelerate and decelerate at the exact points necessary to mirror the moon's real-world movement. In modern terms, this is a mechanical sine wave generator. Imagine the math required to calculate that offset. They were hard-coding the laws of physics into bronze, but it gets weirder. The back of the device featured 2 large spiral dials. One was a 223-month calendar used to predict eclipses. It would tell you not just when an eclipse was coming, but what time it would happen and what color the moon would turn. The second dial tracked the Pan-Hellenic Games. Yes, this 2,000-year-old PC had a built-in sports tracker for the Olympics. How did they do it? They used compasses, rulers, and incredible patience. Every gear had to be perfect. If one tooth was off, the entire program crashed. It represents a level of mathematical understanding that we assumed the Greeks only knew in theory, not in practice. The scariest thing about this machine isn't that it was built, it's that it was forgotten. When the ship sank in 60 BC, the secret of the gears seemingly sank with it. After the fall of the Roman Empire, The knowledge of how to calculate and cut complex gear ratios vanished from Europe. For the next 1,000 years, the most advanced technology in the West was the watermill. It wasn't until the 14th century, with the invention of the first mechanical cathedral clocks, that humanity finally caught back up. If the knowledge in that box had been mass-produced, we might have had the Industrial Revolution during the Crusades and landed on the moon by the year 1000. We often suffer from chronological snobbery, the idea that because we have iPhones, we are smarter than the people of the past. But modern engineers tried to rebuild the Antikythera mechanism using only ancient tools, and they struggled. It took a team of the world's best watchmakers and scientists years to replicate what one Greek workshop did in a single lifetime. It's a reminder that human intelligence is a constant. It's only our documentation that fails. The Antikythera mechanism is a humbling reminder that technology isn't a straight line upward. It can be lost. It can be buried under the sea for 2 millennia. So next time your code won't compile, just remember, someone 2,000 years ago was debugging bronze gears with a hand file just to track the stars. If you found this dive into ancient tech interesting, hit the subscribe button. Let me know in the comments, what lost technology do you think we're still missing?